Hey guys, Miss Nelson here. I'm going to take a minute to go over the 6 weeks scope and sequence to help y'all be able to relay this to the students as smoothly as possible. The second 6 weeks has been an area of growth for us in the past where the flow hasn't been as smooth as we would like it. And we had a conversation last year in the middle of this unit, or the 6 weeks, that helped us be able to stop and get our students on the right track. So if you would like to join me and pull up some resources that we have, I have our detailed YAG pulled up with all of our TEKs here, and then I also have the Lead Forward document that has all of the TEKs for this second 6 weeks checked off and pulled up. So that's what I'm going to be talking to. This is also over here a picture of something that we had talked about last year. And so I'm going to be just using this to help us understand the flow of the curriculum. So let's dive in. One of the first things I want you to notice is Unit 4, the way it is titled. It is titled Developing an Understanding of Slope and Y-Intercept. So we are not expecting them to master slope and master Y-intercept at this point. We're just trying to develop an understanding. They come to you from 7th grade with maybe hearing these words slightly, but we like to stay more on rate of change when we're talking about slope in 7th grade, and then we're also wanting to stay more talking about initial value or starting point when we talk about the y-intercept. So this is when you're going to be transitioning your students over to this language, more algebraic thinking of slope and y-intercept. You have to be careful to stay in our lane when it comes to these two units, and don't go outside of what we need to teach. And it is in our nature to go there just because we naturally want to talk about how do you gain an equation from 2 points, which is not necessary, and I'll talk about those things here in a little bit. So just really try to stick to these TEKs as best as you can, and use this to help clarify your thinking in the future if you need to. So developing an understanding of slope, if we look at the first TEK, 8.4a, the first part is use similar right triangles to develop the understanding. So if we look at how it's been tested in the past, it is a graph with two similar right triangles. This will help them start to recognize that you are looking at the rate between your x and y values. So how, and you don't have to, and you shouldn't be bringing up things like rise over run or things like that yet. We are just trying to develop that slope equation with your change in y's over your change in x. So they should be able to look at one of these type of problems and identify the difference in the y's over the differences in the x's. So they need to be able to look at 2 points and say, okay, we are going to show that the difference in the y's and over the differences in the x's is the same for these two similar right triangles. So that's what you're going to start out with. Identify, this language of slope, and that it's what is here on our graph. Okay. So then on 4C starts to talk about using the data from a table or graph. Okay, so we're just going to be given a table or just given a graph, and I having to identify the rate of change or slope. So both of those those words here, those vocabulary words, are used. This is where you can start transitioning your kids from what they've known in the past to what they're expected to know. And then also y-intercept. These are going to be given in mathematical and real world problems. So let's look at how that looks at 4C released questions. So you're going to be given every single time a table, and then asking, which one is correct, which one is true, looking at maybe the slope or the y-intercept of this table. Given a table or a graph, ask what the slope is. For, again, another table, ask what the slope and y-intercept is. So you're always going to be given a graph or a table. Here is a graph. And then which one best helps here. And this is lastly a question where you're given 2 points. Ask what the slope and the y-intercept is. So they should be using their change in y over change in x equation here, and then also identifying where it is crossing the x-axis here, or y-axis here, excuse me. Okay, so that is going to wrap up Unit 4. That Unit 4 is very short and sweet, and it's just 2 TEKS, but it's just developing the understanding of it. Looking at word problems is not in this unit. All we're going to be doing is looking at tables and graphs, and then also looking at them on a triangle. They're similar right triangles. Unit 5 starts jumping into proportional and non-proportional functions. Okay, notice it's titled here. We're going to stay in proportional functions for a while before we introduce non-proportional functions. And if you notice, non-proportional functions is addressed one time here in 5b, one time here in 5f, and then one time here in 5h. So non-proportional relationships, examples like y equals mx plus b, are not the big focus in this unit. It is proportional and non-proportional. So let's start out with just looking at 4b. So 4b is using the verb graph proportional relationships. So they're going to be expected to look at a proportional relationship and graph it, and recognizing that it's a unit rate and that the slope is that unit rate. So let's check out 4b from the beginning. Okay, so you're going to given a proportional relationship, they're going to have to then graph that proportional relationship. Again, a proportional relationship and graph it. Given the proportional relationship and graph it. So see the trend here. 4b is a readiness standard, and we are going to expect them just to be able to identify the graph that matches this proportional relationship. This is the first one here, and it was tested in 2016, so it's not that great of a question, but it's given the graph and asked for the rate of change. So, but vast majority of them are given a proportional relationship and being able to graph it. Okay, so that's how 4b is going to start out. We're going to stay in proportional relationships. We're not talking about any other y-intercept except for it is going through your 0, 0. So then we're going to jump into 5a. 5a is represent linear or proportional situations with tables, graphs, and equations. So let's jump up here to jump down here to 5a. 5a is going to give you a proportional situation and ask you for it in a table, a graph, or equation. So it's only been tested twice, and both times it's been tested given the situation and come up with the table, but it could be tested also in the future given a situation, come up with the graph, given the situation, come up with the equation. But all of these are just going to be giving situations and then coming up with these pieces here. So that's where you want to keep your kids, reading situations and coming up with the tables, graphs, and equations from that. All right, next one we're going to look at is 5e, because 5e stays in the proportional piece because 5E, direct variation is a proportional relationship. So you're going to want to keep them there, and this is where you can even have them set up proportions if you want. But these right here you could solve for both times it has been open-ended that has been tested, and you can solve for the missing value. But again, these are proportional, and the starting value would be 0. Okay. Next one we are going to talk about is 5B. 5B is the first time they're going to see a non-proportional situation. It is a lot like 5A in the fact that they're going to be given a situation and expected to come up with a table, graph, and equation. So 5B, we can look at, is right here. It has been tested only a few times also, so it gives you a non-proportional situation, and they are expected to come up with the matching table, graph, or equation in y equals mx plus b. This is where you have sometimes the want to start to talk about, let's take 2 points, come up with an equation from y equals mx plus b, and that's not the case. We're only going to be given a situation and then expected to come up with the equation here. So easy enough. What's the starting point, and then what is the rate of change? What is the slope? So here also another problem, given a situation, come up with the table, graph, and equation from those. So these 2 examples have given tables and graphs. Not one of the examples has given you an equation form, but it is possible that you could be asked what is the equation given the situation. All right, 5F is to distinguish between proportional and non-proportional situations. So we're going to be looking at 5F. Let's get what those look like here. The couple times it has been tested in the past has been just graphs. But the TEK does say it could be in tables, and it could be in the forms of y equals kx or y equals mx plus b. So they're going to have to say which one's proportional, which one is non-proportional. Pretty straightforward. These 4 answer choices could be tables. These 4 answer choices could be graphs. Or could be equations and other options there. Okay. When we're still sticking to the proportional, non-proportional, we're looking at what those look like. We're going to look at 5H. 5H is going to be looking at the situations and identifying whether one is proportional or non-proportional. So it says from mathematical and real-world problems. It has been given in the past only from real-world problems. So these are the 2 examples that you'll see there. Straightforward, just answer choices and picking which one is proportional, picking which one is proportional here, or not proportional here, and then proportional here. There are 2 other TEKs that we have not talked about that sort of can be taught in isolation, and as identifying functions as a set of ordered pairs, tables, mappings, and graphs. So now that you've talked about whether something is proportional or non-proportional, let's talk about when it's neither. In a proportional and non-proportional relationship, always goes through x and y, and only has, using that language, one value of x for each y, and you can start introducing, all right, here's what other functions might look like in mappings, tables, and graphs, and which one is a function in y. So that's what 5G is about. And lastly, 9A. 9A is what we feel like is systems, but you do not have to teach the students how to write a system from scratch. All you have to do is look at a graph